I'm Nico Acosta. I'm the co-founder and CEO of Propel. Propel is an analytics backend as a service for building customer-facing analytics experiences. I spent almost a decade at Twilio building API, data, and AI products. I was employee 65, left when it was like 8,000 plus. So I saw a lot of scaling. I was just saying how crazy it is that most businesses that generate vast amounts of data use their data primarily internally. Very rarely they use it externally. It kind of feels a little bit like software in the 80s, where most of the software was used for internal processes, but not really to power any sort of customer experience. I think data, we're in a similar trajectory of getting the data into powering customer experiences. At Twilio, I spent almost a decade there building all sorts of data products. So I'm the co-founder of Propel, an analytics backend as a service, built for powering customer-facing analytics experiences. Before that, Twilio. Before that, I spent some time at AWS, and I'm a two-time founder as well. So in this talk, there's three parts to this talk. First part, I'm going to share a little bit about the journey building data products at Twilio and building data products that are customer-facing at a massive, massive scale. We were generating 5 billion events per day. The second part, I'm going to talk about how we took those learnings and built it into a platform so that any company could build these without having a massive investment. And the third part, we're going to build it live. I found out yesterday that this is going to be the first ever live coding demo at Data Council. So definitely excited for that. So let's kick it off. When you think about customer-facing analytics, a lot of people immediately gravitate to like embedded analytics, embedded dashboards. I'm going to embed Tableau, embed Looker. And hopefully after this talk, I can convince you that it is so much more than an embedded dashboard. And I'm going to give a shot to defining what customer-facing analytics is. It's like customer-facing analytics are the insights provided directly to you, the customer, about the service or product you are using. And if you look at that definition, it doesn't say anything about the delivery mechanism. It could be an API, it could be a SQL interface, it could be a custom dashboard, it could be an embedded dashboard. And when you look at the most successful customer-facing analytics products, they vary, right? Stripe Sigma, right? Paid product, they productize all their data in Stripe, has a kind of SQL-like interface. What we did at Twilio, Voice Insights, an in-product dashboard and API for real-time voice troubleshooting and debugging. And then this is one of my favorite, the Spotify Wrapped. At the end of the year, Spotify tells you, hey, here's how your year looked through the lens of what you listened. You'd have like a lot of trouble thinking about like the Spotify Wrapped experience with a Looker embedded, right? It's not. So hopefully, it's very clear that the world of customer-facing analytics is just so much broader. But what do the best customer-facing analytics experiences have in common? And I have Propel t-shirts for whoever gets it. Any takers?
Flexible.
Could be.
Real time.
Could be.
And personalization.
Also could be. Yeah. Oh. Yeah, all these are good attributes. What is the single universal currency of customer value? Experiences that customers are willing to pay for. If you look at what we did at Voice Insights, what Stripe did with Stripe Sigma, they're paid products. They're willing to pay for them, right? That is the best indication of customer value, is a product that customers are willing to pay for. And what makes it so that customers are willing to pay for? A lot of the things you all said. First, sub-second query latencies. If you log in to your Stripe dashboard and that takes 25 seconds to load, it completely kills the product experience, right? That's a no-go for a customer-facing experience. The second thing is data freshness. If you're in the Shopify dashboard on Black Friday and the data doesn't show up for the next 8 hours, it's game over. You don't know what's going on. It needs to be sub-minute data freshness. And third, you need to be able to consume it multiple ways. You need to be able, if you want an API, if you want a UI, if you want an embedded dashboard, if you want a SQL interface, the art of building customer-facing analytics is really distilling what is the right delivery mechanism and keeping your mind open to what the customers need. At Twilio, we were building with massive scale. We were processing 3 terabytes per day, over 5 million events per day. And these events came from all the calls that went through the Twilio network. So for those that are not familiar with Twilio, it's a communications API platform, now big publicly traded company, massive scale. It powers a lot of the brands that you know and use, like Uber, Zendesk, and it's an SMS, voice, and now like a bunch of other things API. But every call for every hop on the network would send an event every 10 seconds. So we understood what was happening with the calls. And then the events came from the browser, from a WebRTC browser, where, for example, a contact center agent was taking a call, or from the voice gateways that were kind of our server infrastructure. And that's why it was like such a crazy amount of data. It was all processed in real time. And then it was powering 3 mission-critical applications. The first one was the product, Voice Insights, that customers used for real-time insights and debugging. But one of my favorite things was that it was not only a visualization thing, but we also had all our applications that used it. The fraud detection team used all the data from Insights to run their ML algorithms to do fraud detection. And if you're not familiar with telecom fraud, I would really not recommend it. It's a dark corner of the internet, but it's really, really nasty. And then the third thing was carrier routing. We had like a server-to-server use case that the routing engine would query Insights to run their algorithm and prioritize or deprioritize routers, carriers in real time. And when you run, if you're Twilio and you run a network at a global scale, just a lot of things go wrong. You have customers taking calls from their WebRTC browsers, from like the regular browsers, with kind of less than optimal internet connections. Everybody blames the service provider, and then the service provider, whether it's, say, Zendesk or Twilio or whoever's running the application, just needs good visibility to know what's going on. And this resulted in that we were getting a lot of reports from customers saying, hey, I need to see data this way, I need to see data that way. A simple dashboard wouldn't really cut it. And it ended up generating a lot of ad hoc data requests that it was drowning the team. And then the different customers wanted to see things differently, either through the delivery mechanism. Some wanted to query SQL, some wanted a dashboard, but also like their unit of analysis was different. For example, Uber analyzed everything by city, because they have a P&L and a GM by city, and everything works by city. Zendesk analyzes, it's a SaaS company, so analyzes everything by customer or by product feature. Right? Other companies had other things. And that's when we launched Voice Insights that offered a UI and API and event streams for all this quality data. And the results of it, and I'll talk a little bit on how we got to the sub-second latencies, the real-time transformations, and how we unified across multiple data sources. But the 3 years after we launched Voice Insights, we managed to grow the voice business 10x. It really gave customers the confidence to scale. It freed up the teams to do their job instead of answering ad hoc data requests. And the product itself became one of the fastest revenue growing products at Twilio. So it was a paid product. We'd always say you'd be irresponsible to run voice without voice insights. But you can see, if you've ever built a data product, you can see a lot of tension building up here, right? 5 billion events per day and sub-second query latencies, right? You're doing slicing and dicing by a ton of dimensions, and you have the requirement of sub-minute data freshness. And in voice, we were one of the profit centers of the company, so we were not going to ruin our P&L. This stuff is really expensive to run, and we were a profit center, so we could not just like take on the cost. And we realized it comes down to a fundamental trade-off, and data at scale has this fundamental trade-off between cost effectiveness, performance, and flexibility. And the thing with this trade-off at scale is that you can have 2 of them, but not all 3. And you can have a very flexible, you can query by anything, you save the raw events, and you can throw a lot of compute at it. It'll cost, but you'll have performance and flexibility, right? If you aggregate, you'll lose flexibility, but you'll have performance and cost effectiveness. The trick with this is that it's typically seen as an engineering decision. It's typically seen as like, oh, the data team has to make the decision. But what we ultimately realize is that the team that's closest to the customer is best positioned to make this. So at scale, as I said, you'll get 2 of the 3, but not all 3. And we approach this as a product decision. What does the product need to look like, and work backwards from that? And I led the product effort here, and I would go to my data team, and then they start asking questions like, well, what access patterns do you need? So all of them. How fast do you need the data? Sub-second latency. How fresh do you need it? It's like, I'm the product person. I want everything. If you don't tell me how much it costs, I'm going to say I want everything. And then when we started building this inside of my team, it's like, okay, we'll need to make some trade-offs here, because this is going to cost us a lot. And this is where we landed. Not necessarily perfect, but cost efficiency was really important. Performance was really important. We decided to aggregate in UTC. Went with a base set of metrics, a base set of aggregations, and a set of predefined dimensions. And for this product at that time, that was a good decision. But it's not a recipe for every product. So kind of what I encourage everyone to do as they think about their customer-facing data products is kind of go through that framework and think, what are the right trade-offs they need for their product? And it might be different, right? If you're the main Stripe dashboard, like you want it to be fast, you want it to be cheap, right? And you might sacrifice some flexibility. But if it's a drill-down dashboard in another part of the product, that trade-off might be different, right? So it's not a single decision for everything. And what we did at Twilio, this is roughly the infrastructure. We had our API that ingested events, landed all the raw events. Key thing, always land the raw events, save the raw events in S3 just as they land. We had 2 Spark applications, one that did the streaming aggregation for the metrics, the other one that took that and did the trend processing. And then at the time, we used Elastic to surface to the API, the UI, and some streaming applications that we had. The key thing here was that we controlled this end-to-end. But even when you control things end-to-end, this is a very deep belief that we always had. It's the data quality is the responsibility of the producer. You have to define what the event looks like, what the data looks like. And this is what our event at Twilio looked like. And you could see a couple of things. One is that you cannot always trust the timestamp at the source. Sometimes the events were generated by end-user browsers. You can't trust the timestamp of that. So we always logged our kind of like our event received timestamp. We use the ID as our dedupe key, and we have an extensible way to do the metrics and to add new dimensions if we wanted to. And then these were like more interfaces that we had for the events and the aggregations with like the sampling windows and everything. One trick that we did that was pretty cool was last one you see the dimension hash. So we saved a hash of all the dimensions, and that helped us go back and do the trend analysis really, really efficiently. Because when you do trend analysis, you'd want to compare an event that's coming in that has the same dimension hash as you want to compare events with the same dimension hash. So when you're dealing with this type of volume, that's a really cool trick that you can do. But then we realized, well, we built this at Twilio. A bunch of teams wanted it. All our customers wanted it. Why don't we make this a platform? And that's how Propel was born, a platform for building customer-facing analytics. And we learned a couple of things. The first one was that as we saw companies think about their roadmap and their analytics roadmap, there was a tendency to start with like, hey, I'll just ship a simple dashboard and call it a day. Simple dashboard. It won't be that much work, and we'll make it better later. And then companies slowly start slipping into the low-value, high engineering effort territory. It's like the queries become slow, data's not fresh enough, customers need more filters, more data is needed there, they need to transform, the UX kind of sucks, so they need to wrestle with customizations. And it's really easy to end up, if you think about like, let's build the simplest thing first, it's really easy to think to end up in this high effort, low value territory. And you want to be really in the low effort, high value, which is you have to think about it from the customer's perspective, not what's easiest for you, but like what does the customer really want? And if I were to ship voice insights again today, I'd do a couple of things differently. Probably the first thing that I would do is launch a SQL connector. Customers like Uber, like Zendesk, like if we could offer them a SQL interface that is real time, that is super fast, to query all their voice insights data or all their Twilio data, they would have been thrilled. And that would have unlocked a whole set of value for our high value customers. It could have been a paid product that we could have made a ton of money and shipped way faster than we did our kind of very detailed in-product dashboards. But then you'll say, well, not all customers, not all users are kind of familiar with SQL. Some business users just want to look at a dashboard, right? That's where the second thing I would have done is shipping a white label reporting portal. And then you kind of go down the list. Then you can ship them an API. Then you can ship them an embedded dashboard. Then you can ship, once you have a set of a very clear view of what the customers want and what the long tail customers want, you can build custom in-product dashboards. So as you think about the roadmap, think, okay, what is the first thing I can ship? What do my customers want? And kind of a couple of parallels between what we did at Twilio and what we're doing at Propel. At Twilio, we had an API ingestion only. Propel supports ingesting data from multiple data sources, from Kafka, from Snowflake, from webhooks. At Twilio, we did Spark-based streaming aggregations. Twilio has Propel has SQL-based real-time transformations. We work with customer-provided dimensions and aggregations, so you can define whatever you need. And then similarly, you can consume the data via dashboards, via APIs, via SQL, or via a reporting portal. So this is high level how what Propel looks like. You can break Propel into three parts. Ingestion service gets data in. The core of Propel is powered by ClickHouse. Data pools are our implementation of ClickHouse tables optimized for entity data or event data. Materialized views help us transform that. And on top of that, we have metric definitions, APIs, access policies, and a React UI kit to build the dashboards. And then access controls, and then two interfaces, an API and a SQL interface that you can use to power your in-product dashboards, your SQL connector, your report center, or embedded dashboards. So let's see it live. At Propel, we love tacos. So all our demos are taco solved. This is our imaginary SaaS company. We're going to build kind of what takes a couple quarters to build. We're going to build it in 5 minutes. This is where we're going to ingest data from Snowflake, ingest data from Kafka that comes from a Postgres database. We're going to transform it in real time. We'll set access controls. We'll expose it via an API. And we'll pipe it into our dashboard. So the first thing I'll show you is just our taco solved. Plain, vanilla, Next.js app. All these are Propel's React components. They're pre-wired, pre-integrated with the API. This took one of our front-end engineers like a day and a half to build. There's nothing special with it. It's just a Next.js app. The only problem is that it doesn't have data, right? So this is Propel. The first thing you'll see are the data pools. I've already connected Snowflake, so I have kind of my dimension tables, or like my entity tables coming in from Snowflake. So these are restaurants, tacos, salsas, and tortillas. And we're going to bring in our streaming data. The streaming data comes from Kafka. The connection is pretty simple. Like you just give it the Bootstrap servers, your credentials, and you can connect any Kafka cluster. Here we introspect the Kafka cluster, and we'll create, let's bring orders first. This is completely schemaless, so it'll, doesn't matter. We will always ingest the data. We'll give it the timestamp, and we'll call this tacosoft raw orders. And we'll let that bake. And we'll bring another one. So the schema you can imagine, there's the entities, tables, restaurants, tacos, restaurants, salsas, and then orders and order items. Every order item belongs to an order. Cool. So here we have our records live already ingested, and the raw order items is in the process. But when you look at this data, it's kind of nasty. It's a Debezium stream that comes through Kafka. This is just like a huge payload. So when we think about analytics, it's kind of nasty to deal with this. So we're going to transform it. We're going to clean it up, and we're going to use it in our app. Look, we've got all the records. We're ready to go. So what we're going to do here, so you can create a materialized view that essentially takes data from one data pool, transforms it, puts it in a second data pool. You have a whole wizard here to create materialized views. We are going to do it via the API because it is just faster. So here we've got our query. In our query, we're essentially Debezium gives us a timestamp in microseconds. So we're converting that to an ISO timestamp. We're joining with the restaurants table so we can denormalize and get the restaurant name. And that's pretty much it. Cool. And we're going to do a quick change of name here. And then we're going to create a second one that is order items. Similar thing, and we're going to join order items with restaurants, tacos, salsas, tortillas, orders, completely denormalize our data, do the same trickiness with the timestamps, and then do some calculations. We have quantity, we have price, we want to calculate total price. Simple stuff, but really trivial to do in SQL. Oh, 1 second. There we go. good. You know that it's real. We're going to change this name to Tacosoft order items. Still populating. There we go. And you'll see here that we have our denormalized tables that look much, much, much prettier. First thing we do is that we automatically get an API. So if we go to our friendly Postman, again, you can see we get a time series API. So we query 75 milliseconds, not bad for latency. And you get a time series API that you can then take that, plug it into any charting library. You can plug it into Propel's UI components. You can use it however you want. It does all the nastiness of time series of like zero filling granules that don't have data so that when you render it, it renders correctly. You have a leaderboard API. So if you wanted to see, OK, which ones are the top taquerias by orders, and if you live in San Francisco or going to San Francisco, highly recommend these. So here we got our leaderboard. You can do a top K type of list really, really quickly. So, and there's a bunch more APIs. If there is something that a particular API doesn't quite cover, a use case that doesn't quite cover, you can always throw SQL. So if I say, hey, I want to see the orders group by time of day, you can write your own SQL, put it in a GraphQL API request, and you have their orders by time of day. Now we go to our Next.js app, and we're going to change we're going to give it the data pools that we just created. And boom, we have now data flowing into our app. And we ship this, great. Day one of the launch, day one, we get customer feedback. It's like, the graph looks good, but like, I don't know, day granularity doesn't quite cut it. We need our granularity, right? And that's where the teams go, whoa, 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 whoa. We're aggregating by day, just like, forget it. Like, this will be like maybe next quarter. With a platform like Propel, you go, okay, we need to do, say, our granularity. Great. And boom, you have our granularity just like that. And then if you want to give your customers SQL access to this data, so one thing, here are all the components. We have kind of two types of components. One that are data providers so that you can use any charting library that you want. And two, the Propel components that are kind of more full stack. And then if you want to give your customers SQL access, this is the data in PopSQL, which is kind of really cool SQL client. And you can see here we've got our data that we just created, that we just denormalized and transformed. So that is it for the demo. So in, I think it was less than 5 minutes, we saw how we could ingest data from Snowflake, ingested data from Kafka real time. We flattened that JSON. We enriched it with our data sets. We served it via an API. We saw different types of APIs, including the time series. We built a custom React dashboard, and we used Propel React components. So before we leave, if you remember 3 things from this talk. The best analytics products are those that customers are willing to pay for. Just like any other product, it's no different. So the best proxy for customer value is if a customer is willing to pay for it. Start there, work backwards. Second thing is that there's always a fundamental trade-off between cost effectiveness, performance, and flexibility. the closer you are to the customer, the better spot you are to make that trade-off. It is scary how many times that trade-off is made by a team that is really, really far away from the customer. And the other important thing is how quickly can you iterate on that. You won't get it right the first time. Iterating between that cost effectiveness, performance, and flexibility, and the speed of that iteration is really, really important. And lastly, the highest value, low effort products are not always obvious. Don't assume that you'll start with a simple dashboard and that's the beginning of your roadmap. Start with the customer value, work backwards, and you might be surprised that a lot of the high value, low effort products that you can ship have a very different shape if you kind of open the spectrum of possibilities of what is customer-facing analytics. So as Carlos mentioned at the beginning, Propel is now generally available. It's full serverless ClickHouse infrastructure with all the application and API tier that we added on top. It's fully self-service. You have a generous free tier. You can get up to 10 gigs of data, enough to kick the tires, and check it out and let me know what you think. Thank you.
All right. Hold on. Let me pass you the mic.
Hey, thank you. Can you talk a little bit about governance and permissioning? Because like with embedded analytics, usually it's something that is very important and becomes a little bit tricky. What's your kind of like best practices for that? You know, different clients, different roles within the clients, see different data. How do you implement it efficiently?
It was a part that we didn't have the chance to show. We have a whole access control mechanism with access policies designed for multi-tenant use cases. So when you're doing internal BI, you have a company of 2,000 people, you can give 2,000 users, right? When you're building customer-facing analytics and you have 450,000 users, you will not want to create 450,000 users and share credentials. So what we do is that we have a dynamic access policy for multi-tenant applications so that you can control for tenant X, they will exactly see their own data via column or row level access controls. And it's fully integrated into the OAuth 2 flow of the API. So that is built into the platform. It's one of the key things that you need to build or you need to solve for when doing customer-facing stuff.
And we can take one more question, but there's office hours afterwards. So I saw your hand first.
How exactly ClickHouse is made securely multi-tenant? Is it ClickHouse instance per tenant, or it's a single ClickHouse instance serving everyone?
Yeah, it's a good question. There's a lot to that question on how it's made secure. We've made a ton of modifications to the ClickHouse to make it multi-tenant and secure. But essentially, we have like isolated processes per customer. But it's not like a hosted ClickHouse. We've kind of decomposed ClickHouse into some of its components and then ran them in isolation. And that's how we can offer fully serverless scale down to 0, while like if you don't query, we don't charge you. And that's the reason we can do that.